Hello students, welcome to my lecture. Today, let's have an introduction about Fourier series. So you can see here, Fourier series is an infinite series representation of periodic function in terms of trigonometric functions, sine and cosine. Okay, you can see here a function f of x can be represented as this using Fourier series expansion. F of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos n pi x by l plus bn sine n pi x by l, where c less than or equal to x less than or equal to c plus 12. And what about this a0, an, bn? These are given here. A0 equal to 1 by L integral c to c plus 12 f of x dx. An is equal to what? An you can see here. An equal to 1 by L integral c to c plus 12 f of x cos n pi x by L dx. And bn is equal to 1 by L integral c to c plus 12 f of x sin n pi x by L dx. So this is the Fourier series. This is the general form of a Fourier series. So let's see some special cases here. So the case 1. Let's see the Fourier series in this case for the interval 0 less than or equal to x less than or equal to 12. That means c is equal to 0. Okay. So here we had an interval in the general form. We have interval c less than or equal to x less than or equal to c plus 12. So what will happen if c is 0? This becomes 0 less than or equal to x less than or equal to 0 plus 12 means 12 only. Okay. That's what you can see here. 0 less than or equal to x less than or equal to 12. That means c is equal to 0. Okay. So here in this form you cannot see any change. Okay. F of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos n pi x by l plus bn sin n pi x by l. Okay. Because we are just changing c here. C becomes 0. Okay. We are putting 0 value for c here. In this expression you cannot see c here. C is not available here. Okay. So in this expression you cannot see this is exactly like the previous form. Okay. Yes. But for A0, AN and BN, you can see the changes. So what will happen to A0? A0 becomes 1 by L integral 0 to 2L f of x dx. Okay. So that C to C plus 12 becomes 0 to 0 plus 12 means 0 to 12 f of x dx. Okay. This change will happen to A0. Similarly, an is equal to 1 by L, that c to c plus 12 becomes what? 0 to 12. Okay, that's what you can see here. 0 to 12 f of x cos n pi x by L dx. Same change you can see in Bn also. Bn is equal to 1 by L integral 0 to 12 f of x sin n pi x by L dx. Okay, yes. Now let's go to case 2, second case. That means for the interval minus L less than x less than L. That means C becomes minus L. Okay. So the interval will be like this if C is equal to minus L. Okay. So what will happen in this interval if you put minus L for C? In this interval, if you put minus L for C, this becomes minus L. And this becomes minus L plus 12 becomes L only. So that's why minus L less than or equal to x less than or equal to L. Okay. The same interval you can see here. Sorry, here minus L less than or equal to x less than or equal to L. That means C becomes minus L. Okay. So f of x is same only because we are changing only this C. We are putting value for C. So f of x equal to a0 by 2 sigma n equal to 1 to infinity an cos n pi x by L plus bn sin n pi x. This is bn. Okay. This is bn sin n pi x by L. Bn sin n pi x by L. Okay. That is same only. A small change you can see here, a0 will be equal to 1 by L integral minus L to L. Okay, f of x dx. So this c, here we had integral c to c plus 12. That c becomes minus l. This c also becomes minus l. So minus l plus 12, l only. Okay, that change you can see here. 1 by l integral minus l to l f of x dx. Okay, similar changes you can see with an and bn also. An is equal to 1 by l. That integral limit becomes minus l to l. Okay, f of x cos n pi x by l dx. Okay, so this c becomes minus l. This c also becomes minus l. So minus l plus 12 plus l only. Okay, that change you can see the integral minus L to L f of x cos n pi x by L dx. Same change you can see here also. Bn is equal to 1 by L integral minus L to L. Okay, f of x sin n pi x by L dx. Okay, this is for the second case for this interval minus L to plus L. Next, we are giving values for this L also. Okay, let's give values for this L. That means first let's give the value pi for this L. So what will happen? See here. So 0 less than or equal to x less than or equal to 2 pi. Okay. Here I have given the value 0 for c. Okay. And we know that if you give value 0 for c, what will happen? We discussed already in the case 1. Okay. If you give 0 for c, this will happen. 0 less than or equal to x less than or equal to 12. And again I am giving another value pi for this L. I am giving a substitution pi for this L. So this becomes what? 0 less than or equal to x less than or equal to 2 pi. Okay, that's what you can see here. 0 less than or equal to x less than or equal to 2 pi. That means c is equal to 0, L is equal to pi. Okay, so now you can see small changes in the expression of the Fourier series. F of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos n pi x by L becomes cos n pi x by pi because L is pi. Okay, so this L becomes pi now. Okay, that change you can see here plus bn sin n pi x by that L also becomes pi. Okay, so we can cancel this pi and this pi and also this pi and this pi. So here this becomes f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx plus bn sin nx after cancelling this pi. Okay. Similarly, what will happen to a0? A0 will be equal to 1 by pi. Okay. That 1 by L becomes, this 1 by L becomes 1 by pi. That's what you can see here, 1 by pi. And 0 to 2 pi. That 0 to 12 becomes 0 to 2 pi f of x dx. Okay. This 0 to 12, the 0 to 12 becomes 0 to 2 pi. That's what you can see here, 0 to 2 pi f of x dx. Same changes you can see with an and bn. Okay, so an is equal to that 1 by L becomes 1 by pi, 0 to 12 becomes 0 to 2 pi, f of x cos n pi x by L becomes cos n pi x by pi dx. Okay, so here also you can cancel this pi and this pi cancel. So an is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx after cancelling that pi. Okay, so this an becomes, okay, this an 1 by L becomes 1 by pi, 0 to 12 becomes 0 to 2 pi. Okay, that's what you can see here. 1 by pi integral 0 to 2 pi f of x cos n pi x dx. Sorry, f of x cos nx dx. That is our an here. Next, what about bn? So bn, regarding bn, this bn is 1 by L integral 0 to 12. That 1 by L becomes 1 by pi, 0 to 12 becomes 0 to 2 pi. And this L also becomes pi. Okay, so this BL becomes 1 by pi integral 0 to 2 pi. Okay, 1 by L becomes 1 by pi, 2L becomes 2 pi. F of x sin n pi x by L becomes sin n pi x by pi dx. So here also you can cancel this pi and this pi. So you can write Bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx after cancelling this pi. Next, let's move to our fourth case and last case of this lecture. That means for the interval minus pi less than or equal to x less than or equal to pi. Okay. So here from the general form, okay, from the general form of a that Fourier series, c less than or equal to x less than or equal to c plus 12, we are giving two substitutions. Okay. For this c, what we are giving? For this c, that c becomes minus L and that L becomes pi. Okay, we are giving these two substitutions. Then see f of x equal to a0 by 2 plus sigma n equal to 1 to infinity a n cos ns plus b n sin nx. Same thing you can see here in the third case. Okay, after substituting pi for L, pi and pi got cancelled. What happened here? F of x equal to a0 by 2 sigma n equal to 1 to infinity a n cos ns plus b n sin nx. So same thing also you can see here. Here also we did the same substitution. L becomes pi. So that too, pi and pi got cancelled. You will get cos nx here. Here you will get sin nx only. Same thing you can see here. Okay. Then see a0 will become 1 by pi integral minus pi to pi f of x dx. Okay. Yes. So here you can compare with this. It is similar to this form. Minus L less than or equal to x less than or equal to L. Okay. And that L became pi here. Right. Minus L less than or equal to x less than or equal to L. Here that L becomes pi. So minus pi less than or equal to x less than or equal to pi. So you can compare with the second case. You can compare it with the second case. So what was our a0 in the second case? 1 by L integral minus L to L f of x dx. So all these L becomes pi. So 1 by L becomes 1 by pi, minus L to L becomes minus pi to pi. Okay, that's what you can see here. a0 equal to 1 by pi integral minus pi to pi f of x dx. All right. What about an? What was our an in the second case? See an in the second case. 1 by L integral minus L to L f of x cos n pi x by L dx. Okay. Here all of these L becomes pi. So 1 by pi. This becomes 1 by pi. Minus L to L becomes minus pi to pi. F of x cos n pi x by L become cos n pi x by pi. Pi and pi you can cancel. So at the end, you will get this only. 1 by L becomes 1 by pi. Minus L to L becomes minus pi to pi f of x. Cos n pi x by L becomes cos n pi x by pi. Pi got cancelled. You got cos nx only. Okay. And same thing you can see with Bn also. Okay, so what was our Bn in the second case? Bn was 1 by L integral minus L to L f of x sin n pi x by L dx. So this 1 by L becomes 1 by pi, minus L to L becomes minus pi to pi, sin n pi x by L becomes sin n pi x by pi. Pi will get cancelled. So 1 by pi integral minus pi to pi f of x sin nx dx. Same thing you can see here. 1 by pi integral minus pi to pi f of x sin nx dx. I hope everything is clear for you. In the upcoming videos, we will discuss more about Fourier series. Okay, we are stopping now. Thanks for watching. Bye bye.